Okay, so now we're going to talk about the review questions. This should be an assessment for you to say, yeah, I got it, I know what I'm doing, or no, I don't understand this. I need to go back and redo what was done in class and think a little bit more. And it might help you to draw pictures or diagrams and write things out. Okay, so question number 1, a rigid metal tank contains oxygen gas. When additional oxygen gas is added to the tank at the same temperature, and then you have 4 what ifs, or what happens. So first thing I want to point out to you is this word rigid. So rigid means that you probably have, like, you've got a metal tank. Rigid means that the size, or more specifically to us, the volume of the container will not change. Because if that container expands, it will explode. And if that container is compressed, it will collapse. So the size of the container, the volume of the container is what it is. So A, what happens to the volume of gas if you add additional oxygen gas? Nothing. There's nowhere else for it to spread. And it said rigid, so there's no change in volume. B, what happens to the pressure of gas? Okay, let's think. If I add gas, I am adding more particles. So those particles are hitting the side of the container more times because I've got more particles. So the pressure should increase. What happens to the average speed? Well, average speed relates to the mass of the gas. It's oxygen gas initially, and it's oxygen gas added in. And the temperature is the same. It doesn't change. So the kinetic energy is the same, and the molar mass is the same. So nothing. There's no change. What happens to the average distance between the gas molecules? Okay, in this case, it's going to decrease because, let me go down here. If I have a container with gas initially in it, and then I add more gas, and the volume of the gas cannot change, then I'm a more densely populated gas sample. So there's less space in between two molecules. So that space in between is going to decrease. All right, next question. At constant pressure, which graph shows the correct relationship between volume of the gas and its Kelvin temperature? So I want to know volume and temperature. If something is held constant, that means there's no change, so don't include it in your graph. So think back to the balloon example. If I take a balloon and I heat it up, so the temperature goes up, then the balloon will start to inflate, because the balloon's volume can change because it's elastic, it can stretch. So its volume will increase because the gas has more kinetic energy when the temperature increases. So the volume can get larger. So this is a direct relationship. So I need a graph that shows a direct relationship. This shows no change. This is an inverse relationship. And this is an indirect relationship. So C is the answer. As the temperature goes up, so does the volume of the gas. Question 3. Which graph best shows the change in volume of 1 mole of nitrogen gas as the pressure increases and the temperature remains constant? Okay, if temperature is constant, do not include it in your graph. I want to know what happens to the volume as the pressure increases. So think about the marshmallow example that we did in class. The more I push down on the marshmallow, the smaller the marshmallow gets. So as the pressure is increased, the volume decreases. And remember I told you this is Boyle's law. And Boyle's law is the only gas law that shows an inverse relationship. So this is no change. This is a direct. This, you got no change, preceded and followed by a direct. That's just wrong. So this is your answer. As the pressure gets larger, the volume gets smaller and smaller. Okay? Pressure increases, volume decreases. So A is your answer. For number 4, a sample of an ideal gas is cooled. So I've got a change in temperature from 50 degrees Celsius to 25 degrees Celsius in a sealed container, constant volume. So constant volume means no change. What happens to the volume of gas? No change, nothing. Because it says the volume is constant. What happens to the pressure of the gas? Okay, in this case, the temperature is decreasing. So the gas molecules that did have a lot of energy, now their temperature is decreasing. So they're starting to compress and get closer together. And if they're not moving as fast, then that means the pressure of the gas is going to decrease. Because temperature and pressure are directly related. If one goes up, the other goes up. If one goes down, the other goes down. See what happens to the average kinetic energy? Okay, that should be code in your mind for temperature. If the temperature drops, that is average kinetic energy, so it will also decrease. I'm sorry, I have that twice. All right, next. False. Sorry about that. I forgot to paste some of these over from a different file. Okay, if the volume of a gas is doubled, so I'm going to double the volume, make the volume larger, from 2 liters to 4 liters, what happens to the pressure? So I want you to think back to your marshmallow example. If I take the volume of a marshmallow and I make it larger, now there's more space, there's more area for those gas molecules that were originally trapped in that marshmallow. There's more space for them to move. So that would mean that the pressure will decrease, but how much will it decrease by? If the volume doubles, then the pressure will decrease by a double. It will decrease by a half. So it will decrease by 1/2 because this is an inverse relationship. So if the volume is doubled, the inverse of 2 is 1/2. So the pressure will be cut in half. Number 6. Why could the pressure of a gas sample at a constant volume decrease by 50 millimeters of mercury, by 75 millimeters of mercury? All right, volume is not going to change it. How could the pressure decrease? Well, I know that pressure and temperature are directly related. If the pressure goes down, the temperature also had to go down. So if I decrease the temperature, that will decrease the pressure. So your answer here is a decrease in temperature. Okay? Or, and this wasn't specified in the question, if the moles of gas are removed, from the container, then there's less collisions because there's less moles of gas, so the pressure is lower. Question number 7. You have Stafford test tubes below, and they had a different gas in each one. So helium, neon, argon, krypton. When the tubes are all uncapped, so if I take all these caps off at the same time, and they're all under the same conditions of temperature and pressure, from which tube will the gas diffuse at the fastest rate? So right now they all have the same kinetic energy because they're at the same temperature. So what I'm really looking at when I'm talking about rate, I'm talking about a speed or a velocity. How fast will these guys move out of the tube? Remember, smaller molecules move faster, bigger molecules move slower. All of these gases are actually atomic gases because they're noble gases. They're not molecules, but it still works same way. They're gas particles. So the smallest gas particle is helium. Helium has a molar mass of about 4. As you go down the periodic table in group 18, the gases get bigger and bigger and bigger. So helium will diffuse the fastest, and krypton will diffuse the slowest. And it's all related to the mass of the gas. Alrighty, last question. You have 5 balloons shown below. They're all identical. They're at a temperature of 25 degrees Celsius and a pressure of 778 millimeters of mercury. And each balloon contains the same number of moles of a gas. Okay? So you have carbon dioxide, oxygen, helium, nitrogen gas, and then that CH4 is methane. So question A is asking which balloon contains the greatest mass of gas and why? Because these are all at the same temperature and at the same pressure, and the balloons are identical, they have the same number of moles of gas. So they also have the same volume. And that's by Avogadro's law. So if all of these, and I'm making a number up, if all of these have 10 moles of gas, then the balloon with the greatest mass would be the balloon that has the heaviest molar mass. So if you do some quick math, your carbon dioxide has got the largest molar mass. Okay? It's got the largest molar mass, it's got the greatest mass of gas, because they all have the same number of moles. Which balloon or balloons contain gas atoms? Okay, so that means not molecules, that means not atoms that have been bonded together, just single atoms. Well, if you stand up here, the only one that I see is just atoms is helium. Which balloon or balloons contain gas molecules, where the atoms have bonded together? So that would be all your other gases. It's got a subscript, it's a molecule. D, which balloon contains particles with the greatest kinetic energy and why? This is a trick. Kinetic energy means temperature. They're all at the same temperature of 25 degrees Celsius, so they're all the same kinetic energy because they're all at the same temperature. E, which balloon contains gas particles with the greatest velocity? Okay, speed. So now I can look and say greatest velocity means lowest or smallest molar mass. Well, helium has got the smallest molar mass by far of any of the gases in those balloons. So helium, and because it's got the smallest molar mass. Okay? F, If a small pin-sized hole was placed in each balloon, which balloon would decrease to the smallest volume? F is asking you an E-fusion question. If I were to pop a hole in each of those balloons, sorry, that's not a hole on this last one, my pen slipped. Which balloon would decrease to the smallest volume? So I'm really asking here, which gas would effuse the fastest? The gas that's going to effuse the fastest, is going to push the gas out of that hole the fastest, is going to be the helium for the same reason. It's got the smallest molar mass. All right, so that concludes the review questions. If there's anything that you didn't understand, then you need to ask your teacher in class, because all of these concept questions will be heavily tested on your test, which is next Thursday, the 17th. Some of these concepts will be on your quiz, which is Tuesday, the 15th. As always, if you have questions, we're available for tutoring. You just have to take advantage of that opportunity. Have a great night. Thanks.